we're going to take a look at how to convert the different bases, such as binary, decimal, and hexadecimal, into one another. And the last video, we had binary, and we were able to convert it into decimal and hexadecimal. So now we're going to take a look at the other two, meaning decimal and hexadecimal, and see if we can convert into the other two bases. So let's take a look at a couple examples where we have the decimal representation, and we convert that into the binary and then hexadecimal. One of the easiest ways to do this is to, again, make the table with the powers of 2 and try to convert that way. All right, so now our powers of 2, and I'll write the numbers, the actual values over top of it. We have 2, 0 to the first, and remember that's 1, 2, 4, 8, 16, 32, 64, and 2 to the 7th is 128. All right, now notice the number we have is 123. So once we get to a number that's bigger than 123, we don't have to use that one because there's no way to be able to do that. And so from here, what we're going to do is we're just going to make a table. And whenever the number that's left over is bigger or is smaller, excuse me, than the original value, then we just put a 1 under there. All right, so we know that 64 is less than 123, so we put a 1 under there. And from 123, we are going to subtract 64, right? And that should leave us with 59. Right? Now, 32, that's less than 59, so we're going to put a 1 under there. And we're going to subtract 32. So each time what we're doing is we're just figuring out the powers of 2 that would comprise 123. So that's going to leave us with 27. Right? And 16 is clearly less than 27. That's going to leave us with an 11. And 8. And unfortunately, 4 is more than 3, so we put a 0 there. But we know that 2 plus 1 is going to give us 3. All right, and so the binary value for 123 is going to be 1, 1, 1, 1, 0, 1, 1 in base 2. That's not the only way to do this, but it's a fairly easy way to be able to convert from decimal to hexadecimal or to binary. And just like we saw before, once we have the binary, then we can move into any of the other two of the conversions. So now what we're going to do is we're just going to take the 1101 and we're going to convert that. So we have 1011, and remember that's going to be a 1 plus a 2 plus an 8, and 1 plus 2 plus 8 is 11, which in hexadecimal is B. So that's our B. And right here, we have to put a 0 in front because that's only going to be 3 bits and we need 4. So 0, 1, 1, 1 is 1 plus 2 plus 4, which is 7. All right, so the two answers that we get, the hexadecimal or the binary, excuse me, is going to be 1, 1, 1, 1, 0, 1, 1 in base 2. And then in base 16, we're going to have 7B. So not too bad. Pretty easy for us to be able to work with that. Right? So a secondary example, we have 975, and we want to convert that into both of the other two. So just like we did before, so we have our 2, 0, 2, 1, 2 square, 2 cube, 2, 4, 2, 5, 2, 6, 2, 7, 2, 8, 2, 9, 2 to the 10. Right? And 1, 2, 4, 8, 16, 32, 64, 128, 256, 512, and 1024. Notice 1024 is bigger than 975, so we don't worry about that. All right, and what we're going to do is we're just going to make our table just like we did before. And we know that 512 is clearly going to fit in. Right? So we're going to put a 1 here, and we have our 975 minus 512. That's going to leave us with our 463. All right, now we know 256 is less, and that's 256, and that's going to leave us with 207. And we have 128. Right? So you can see how this goes. So that's going to give us, and it's going to leave us with 79, right? And then we have our 64, right? So 79 minus 64, that's going to leave us with 15. And usually once we get to that point, the rest of it's pretty easy. All right, we know that 32 is bigger than 15. We know that 16 is bigger than 15. And we can subtract 8. We can subtract 4. We can subtract 2. We can subtract 1. And that gives us our binary value, right? So in binary, we have 1, 1, 1, 1, 0, 0, 1, 1, 1, 1 in base 2. All right, so let's hold on to that. Now let's take the different bits. All right, so I'm starting right here, and 1, 1, 1, 1, and that's going to be 8 plus 4 plus 2 plus 1, and that's going to yield 15, which we know is F. And then we have these 4 bits, 1, 1, 0, 0, and that's going to yield 8 plus 4, which is 12, and 12 we know as C. Right? And then we have 2 1s, and then that would be 0, 0, 1, 1. Okay, so right here, we just put the 2 zeros in front, and that's just going to be 3. Right? So in base 16, it's 3CF. Right. So hopefully that's not too difficult for everybody. By the way, if you know a different method for being able to do that, that's perfectly fine. I'm just showing you the way that might be helpful for anybody that's never seen this before. Right. Now, what if we have hexadecimal and we want to convert it into decimal and binary? So again, what I like to do is I always like to get into binary because binary is probably like the intermediary between the two. So 5, let's go ahead and build a binary, I guess, four character binary word, if you would, out of 5. And 5 is going to be, remember, 4 plus 1, which is going to be 0, 1, 0, 1, right? Because remember, it's 8, 4, 2, 1. All right, so that's the last part of it. 2 is easy. That's just 2. That's 2, which is 0, 0, 1, 0. Okay, and then finally A, which is 10, is equal to 8 plus 2. And that's 1, 0, 1, 0. So all I'm doing is just like before, I'm kind of making a table here, all right, and just kind of filling in the blanks. So in base 16, we have 0, 1, 0, 1, or that's the end of it, excuse me. So in base 16, A25 in base 2 is going to be 1010, so that's this one, and then 0010, which is our second pair, and then finally 0101. All right, and that's in base 2. Now, if we want to put that into base 16 or in base 10, excuse me, all we have to do is we just have to add up the bits and take them as powers of 2. Right? So we have 1, 0, 1, 0, 0, 0, 1, 0, 0, 1, 0, 1. Right? And remember, it's 2 to the 0, 2 to the first, 2 square, 2 cubed, 2 to the 4th, 2 to the 5th, 2 to the 6th, 2 to the 7th, 2 to the 8th, 2 to the 9th, 2 to the 10th, and 2 to the 11th. And so that's going to be 1, 4, and then it's going to be 32, and then we have 64, 128, 256, 512, 1024, 2048. And so we just add those up, right? Nice and easy. So if we add this, that's going to give us 2560. I'm just doing this by hand really quickly, and this is going to be 37. So 2597 in base 10. All right. So nice and easy, shouldn't be too difficult, just number operations. All right. As a final example, we have this FB81, all right, and we'd like to be able to convert that. Right? So maybe now might be an opportunity for you to pause the video, try to work through it yourself, and then see if you can get to the answer. Right? If you're still confused, then just keep watching because I'm going to work through it. Right? Now, 1 is just 1, which is 0001. A is 10, and 10 is 8 plus 2. That's, sorry, 1010. B is 11, so that's going to be 1011. Right? So we just added one more. And then F is 15, and 15 is just everything, right? That's 8 plus 4 plus 2 plus 1. And so in binary, this guy going from left to right, F 1111, B 1011, A 1010, and 1 is 0001. All right, that's in base 2. All right, now here comes the fun part, is being able to convert this into our hexadecimal, or I'm sorry, into binary, into decimal, excuse me. So our power is a 2, so this might be easier to where we just pick it off. Okay, so we have a power of 2, which is 2 to the 0, and then we have 1, 2, 3, 4. So we have 2 to the 5th. Then we have 7, 8, 9. So we have 2 to the 7th, 2 to the 8th, 2 to the 9th. And we skip 2 to the 10th, and then we have 11, 12, 13, 14, and 15. All right. So that would be 2 to the 11, 2 to the 12, 2 to the 13, 2 to the 14th, and 2 to the 15th. All right, so this is where we're going to have to get a little bit creative here. And in our calculator, you might have to do some of these by using the calculator just because it's not as easy. So I don't know if my calculator, this screen has the capability to do exponents in it. So yeah, that's just a square. It doesn't have the power in it. Okay, so but regardless, at this point, you guys could go through and figure that out. That's not that big of a deal. But in the next video, what I'll do is I'll add it up just for you to confirm, and then I'll just show you what the answer is in the next video. And then we're going to move on to the last part, which is going to be able to look at the computation of doing 8-bit addition inside of a computer.